Hello friends, welcome to my channel. In this video, we are going to discuss about very important definitions called implicant, prime implicant, essential prime implicant, and a redundant prime implicant. So first to see the definitions, then we will come to the example, then you can understand easily. Implicant, each minterm or max term, that is logic ones or logic zeros. Each minterms or max terms with canonical form is called implicant. Prime implicant. Next, so in which all possible combination of minterms is called prime implicant. All possible combinations of minterm. So those pairs are quad. Those pairs are quads are called prime implicants. Next, essential prime implicant. It is a prime implicant. At least there is a single minterm which cannot be combined in any other way. Those type of prime implicants are called essential prime implicant. Next, redundant prime implicant. It is a prime implicant in which each minterm is covered with essential prime implicant. So those type of prime implicants are called redundant prime implicants. Now the point is, if you want to understand the redundant prime implicant, first of all we need to understand about essential prime implicant. If you want to know the essential prime implicant, first we need to understand the prime implicants. So anyway, let us see the example. So then you can understand easily. Very simple topic it is. First of all, total we need to find the first problem. It is minterms. It is given summation small m of 1, 2, 3, 6. So first of all, how many implicants are there? So 1, 2, 3, 6 means total 4. 4 implicants are there. Next, prime implicants. How many prime implicants are there in this problem? Prime implicants in the sense all possible combinations. So possible combinations, that is this one, 1, 3. And we can also group 2, 6. This is the another possible combination. According to the K-map rules, only 2 pairs. But here, all possible combinations. So all possible combinations means here, including 3 and 2 minterms also we can group here, including 3 and 2. So these two. Right. So total, how many prime implicants are there? That means how many groups are there here? Whether it is a pair or quad. How many groups are there? 3. So 3 groups are possible. So total prime implicants are nothing but 3. So 3 is the answer. Implicants are 4. Next, essential prime implicants. Essential prime implicant means, first of all, it is a prime implicant in which at least a single minterm which cannot be combined in any other way. So let us consider this above 3 prime implicants. From this prime implicants only we need to pick up the essential prime implicant. So essential prime implicant means only one time it is grouped. Only one time it is grouped, that particular minterm. For example, if you see this 1 and 3, this 1 it is grouped only one time, but 3 it is covered. This 3 it is covered in 1 and 3 and 2 and 3 also. Like observe here, this 1 and 3 and this is 2 and 3. This 3 is covered here, and this 3 is covered here. So, but only this 1 and 3 it is covered only one time. So particularly the essential prime implicance is nothing but 1 and 3, and similarly you can say that 6, 2. 6, 2. So this 6 it is covered only one time, but that is the reason 6, 2 we can that particular pair we can call it as an essential prime implicant. 6, 2 because of that 6 which cannot be combined in any other way, that particular 6 minterm. But 2 minterm it is covered 2 times. Anyway, 2 it is covered 2 times. So that is the reason we are avoiding this particular 3, 2 minterms. We are not considering here. So the essential prime implicants from the given prime implicants are 2. So essential prime implicants, it is comes under from the prime implicant itself. So it is 2. Answer is 2. Essential prime implicants. Next, redundant prime implicant. Redundant prime implicant means, first of all, it is a prime implicant in which each minterms must be covered with an essential prime implicant. Each minterm must be covered with an essential prime implicant. Actually, such type of prime implicants are not there. Such type of essential prime implicants are not there. That means if you consider this 1 and 3, this 1 and 3, this 1 and 3, particularly this one, it is an essential prime implicant, particularly if you consider this one, but 3, it is covered 2 times. 3, it is covered here in this way, like 2 and 3, and 1 and 3. The essential prime implicant in the sense that, the redundant prime implicant in the sense in which each minterm is covered with an essential prime implicant. Each minterm must be covered with an essential prime implicant. So that is the reason here. So such type of redundant prime implicants are not there. So when we say the redundant prime implicant means, in that redundant prime implicant, all the minterms are essential prime implicant. All the minterms are essential prime implicant. For example, this 6 and 2. This 6 and 2, if there is any possibility is there, for example, we can say that if 6 and 1, in case it is formed a pair, we can say that is a redundant prime implicant. Okay, but anyway, it is not possible. So the redundant prime implicants are, for this particular problem, it is 0. For this particular problem, it is 0. So implicants are 4, prime implicants are 3, essential prime implicants are 2, and the redundant prime implicants are 0. So let us come to the second problem. I hope you will get the clear idea about this particular problem. So how many number of implicants? So implicants are means very simple: 1, 2, 3, 4, 5, 6, 7, 8. So here max terms are mentioned, min terms are max terms. That's not a problem. Next, implicants. Implicants are completed. Next, prime implicants. So here, all the possible combinations of the min term, all the possible combinations of max terms. So this is the pair, and the min terms which are far away from the other min terms, try to group the first one. Anyway, this type of problem we already discussed in our previous video. So this is all the possible. So according to the K-map rule, this is the way to group the min terms. But we need to check here for this particular problem. If you want to the prime implicants, all possible combinations we can consider. So that is the reason this 5, 7, 13, and 15 also another possibility to group these max terms. So let me write here the total prime implicants 1, 2, 3, 4, and 5. Total the prime implicants are 5. So now the point is, let me write the prime implicants here so that the discussion is easy. 6 and 7, 11 and 15, 12 and 12 and 13. Then 5, 7, 13 and 15. Yeah, so here when we say the essential prime implicant, the very first point is essential prime implicant means it is a prime implicant. First of all, it is a prime implicant. So in which at least a single minterm which cannot be combined in any other way. So 1 and 5, 1 prime implicant, 6 and 7, and this 11 and 15, and 12 and 13, all these are the prime implicant. So all these prime implicant, and this one also, all these prime implicants a particular min terms or max terms, so it is covered only one time, which cannot be combined in any other way. It is a, so that type of prime implicants are called essential prime implicant. So this 1 and 3, 1 and 5, it is a must. It is an essential prime implicant. 1 and 5. And similarly, 6 and 7, it is an essential prime implicant. This 6 minterm, it is covered only one time. This this particular 1 minterm covered only one time. This 12 minterm covered only one time. This 11 minterm covered only one time. But this 15 and 13, 5, 3 covered two times. So why it is this particular 5 minterm, it is comes under pair and it is comes under quad also. This particular 3, it is under particular 3 minterm, which is covered in this quad and pair also. This particular 15, which is covered in quad and pair also. This particular 13, it is covered in pair and quad. So that's the reason essential prime implicants are nothing but these 4 only. Like this one, this one, this one, this one. So these are the essential prime implicant. Then what about the redundant prime implicant? Redundant prime implicant means, first of all, it is a prime implicant in which each minterm or max term, each minterm or max term, which must be covered with an essential prime implicant. So now observe here. This is a we got the one conclusion, that is this 1 and 5 an essential prime implicant. Okay. This 6 and this 6 and this 6 and 7, which is under one, we can say that it is also a essential prime implicant, and 11 and 15 an essential prime implicant, and 12 and 13 an essential prime implicant. Now I mean to say here 5, 7, 15, 13, all these are comes under essential prime implicant. Now such a type of group, this group is called an essential redundant prime implicant. So now the redundant prime implicant are how many? 1. Because in the essential prime implicant, if you observe here, in this essential prime implicant, mainly here the 5, with the help of this 5 and the 7, 15 and 13. The help of these actually these minterms are essential prime implicants only. With that essential prime implicant, whenever if you form the one quad, such type of pair or quad is called an redundant prime implicant. So now the redundant prime implicant, which is nothing but 5, 7, 15 and 13. That's it. Hope you understand now. Let us come to the third problem. Now it is very simple. So 1, 2, 3, 4, 5, 6. So implicants are 6. Then what are the prime implicants? That means all possible combinations. So this one, 1, 2, 3, 4, 5. So total prime implicants are 5. Then what are the essential prime implicant? Essential prime implicant, it is a prime implicant in which at least a single minterm which cannot be combined in any other way. So 5 only one time covered, 6 only one time covered. So this 11 only one time covered. So such type of pairs, such type of prime implicants, 5 and 13. This prime implicant, 6 and 11, this prime implicant, and 11 and 15. Sorry, 11, 6 and 11. Then this is the 6 and 14. 6 and this 14. So this 11 and 18. So 11 and 15. So this is these are the prime implicants. That too. So here, so these are the essential prime implicants, because the 5 which is combined only one way, and this 6 only one way. This 11, it is combined, it is in only one way. So that is the reason these are the essential prime implicants. There is no other minterms like that. So which is at least a single minterm which cannot be combined in any other way. So here this single minterm only one time covered, only one time covered, only one time covered. Next, redundant prime implicants. What are the redundant prime implicants? So in this, observe here. In this only if you want to find the redundant prime implicant, you can find it. So the redundant prime implicants are nothing but it is a prime implicant. So in which each minterm must be covered with an essential prime implicant. Each minterm must be covered with an essential prime implicant means. So here try to answer this one, the redundant prime implicant for this particular problem. How many are there? So yeah, observe here. Anyway, this 5 and 13, if you observe this 5 and 13, 13 it is an minterm. Observe this 13 and this 14 and we know that this 11 and 15, the 11 and 15. So where with the help of this, it is an essential prime implicant. Now we formed another pair with the help of the essential prime implicant. We formed one pair. So that particular pair, it is a redundant prime implicant. Because why it is a redundant prime implicant means this 13 it is covered one essential prime implicant, and this 15 it is covered in essential prime implicant, another essential prime implicant. That means in this redundant prime implicant, these two minterms are covered. And the same way, this is also a redundant prime implicant RPI. That means here this particular minterm 15 it is covered in this essential prime implicant, and this 11 it is covered in this essential prime implicant. So we can say that the 15 and 11, the redundant prime implicants are nothing but this 13 and 15, and here is 15 comma 11. So redundant prime implicants are 2 for this particular problem. Let's come to the last one. So here the implicants are nothing but 5 and prime implicants. What are the possible combinations? 1, 2, 3, 4. And what are the essential prime implicant? Essential prime implicant for this particular problem. The essential prime implicants are 2, because this particular 4 and 5, this 4 it is covered only one time, and this 2 is also covered only one time. So that means what are the two essential prime implicants? 4 comma 5 and 2 comma 3. Now if you observe here, there is no such redundant prime implicants. There is no such redundant prime implicants, because the above discussion it is not valid here. So here this 13 with the help of the 13 it is covered here, the 15 it is also covered here. So we can say that the redundant prime implicant here itself. But we cannot say the 1 and 3 it is a redundant prime implicant. For example, why? Because if you say this 1 and 3 it is a redundant prime implicant, 3 it is okay, fine. But 1 it is not covered, 1 it is not covered here. That's the reason. This is not redundant prime implicant. This 1 and 3. You may think that 1 and 3 it is a redundant prime implicant. No. 1 and 3 it is not a redundant prime implicant. So anyway, so or you can see the 1 and 7 also. 1 and 7 it is itself. So it is also not a redundant prime implicant. So when we say the redundant prime implicant means it is a prime implicant in which each minterm must be covered with an essential prime implicant. Then only we can say that it is a redundant prime implicant. So hope you understand this particular video. If you like this, please like, share, and subscribe my channel. And also this particular video, share to your friends. Then thank you.